Exponential equations. An exponential equation is an equation where the unknown or the variable is part of the index or the exponent. So like this, right? So our exponent right there is a variable that makes it an exponential equation. Right? Exponents in general, when you have something like this, that number right there is called the base. This is called the exponent. When the exponent's a variable, it's an exponential equation. When the variable is an exponent, that's why it's called an exponential function. And in this case, an exponential equation. So how do you solve exponential equations? Well, the key is right here. You want to get the bases the same. Once you match the bases, once you rewrite them to get the bases matched, then you just solve the powers. That's all it is. So if we're going to do this one, to give an example, 2x equals 8. You just have to rewrite 8 to be a power of 2. So 8 is the same thing as saying 2 cubed. I wrote that bad. You have 2x equals 2 cubed, and once you have that, you just solve the powers. X equals 3, and there you go. So let's do an example or two. Solve for x. 2x equals 16. So yeah, what we're going to want to do is try to get these bases to match. Now I can't do anything to 2, but 16 can be right. It's helpful if you know your powers for sure. 16 is the same thing as 4 squared, which again doesn't help me because it's 2. 2 to the 4th is it's also 2 to the 4th. So this side you can write as 2 to the 4th, and this side is 2 to the x. And once you have that, you can just equate the powers. X equals 4. The next one, same idea, but a little more complicated. So I have 3 here. I can't change that. 1 over 27. I could change that. I could write that as 1 over 3 cubed. 27 is 3 cubed. But they're still not the same. This is on the denominator. This has no fraction. It's on the numerator by default. So I gotta flip this up. Remember, the way you flip it up is you change the sign of the exponent. So if that's a 3, that should become a negative 3. So we have that, and now we just solve the powers. X plus 2 equals negative 3. X equals negative 5. Next one. Now this is where it gets a little bit more complicated. At 4x equals 8. Well, you try to get them the same base. 8 is, you can't write that as 4. 4 times 2 doesn't help you. You have to write it as a power. It could only be power. So 8, the only thing I can write that as is 2 cubed. You're like, that doesn't equal 4. Well, I could rewrite this out also. So 4 is the same thing as saying 2 squared. So I'm going to rewrite both of these to get them to match. And you get this. Now remember, power to power, you multiply. So this is the same thing as saying 2 to the 2x equals 2 to the cubed. And now you just solve the powers. 2x equals 3. X equals 3 halves. Next one, 9 to the x minus 2 equals 1/3. So this is 3 to the first power. You can think about it that way. So I'm going to flip it up. That's going to be 3 to the negative 1. On this side, again, I could change 9. Right, you want to go to the same base. And I can't really do anything with 3 besides move it up. 9 I can make 3 squared. So it's going to be 3 squared x minus 2. Now when you solve the powers here, keep in mind you have to distribute the 2. So it should be 2x minus 4 equals negative 1. And then we can solve. 2x equals 3, divide by 2, x equals 3 halves. So there we go. Next one, we have to perfect some of our rules from a couple sections ago. 4x plus 2x minus 20. So how do we solve this? Well, it's set equal to 0. It's kind of in quadratic form. So we want to do this factor here. And how we factor, we have to rewrite this. I can rewrite 4 as 2 squared x plus 2x minus 20. Or another way to rewrite this side is 2x squared plus 2x minus 20. Now this you could factor. Again, a couple ways of factoring it. I just look at it like, okay, this thing is squared and this thing is the first power. It's like a normal, like if they're x's. So you just factor it like normal. Pretend it looks like this. Right, so we're going to factor that. Well, how do you factor that? I need two things that multiply to get negative 20, but add to get a positive 1. That should be x plus 5, x minus 4. But again, it's not an x, right? It's 2x. So we just change this to 2x. 2x plus 5 and 2x minus 4 equals 0. Now we're going to split and solve. So 2x equal plus 5 equals 0, and 2x minus 4 equals 0. Decide to get 2x equals negative 5. That actually cannot happen. This is a power. Power doesn't change the sign above things, so you can't have a negative number there. So that's not possible. Over here, 2x equals 4. Try to get the same base. Only I can change it to 4 right here. So it's 2x equals 2 squared. So x equals 2. That's the lesson.